Concept 7a, graphing quadratic functions. In this section, I'm going to take you through how to graph a quadratic in what we call vertex form. So let's get a couple definitions down. Vertex form is the form of a quadratic function that follows f of x equals a times the quantity x minus h squared plus k. And that's where x and f of x, or x and y, are your permanent variables, and a, h, and k are constants. The vertex of a quadratic is the highest or the lowest point of the parabola, and the parabola is what we call the shape of the graph. It's a U shape. One characteristic of a parabola is that it has an axis of symmetry. That is a line that divides it exactly in half into mirror images. Two other things that we talk about with parabolas are the maximum or the minimum point. And this will be the highest or the lowest point of the parabola. They won't have both, they'll have one or the other. And either the maximum or the minimum will be the vertex. And then finally, domain and range. You've heard those words before. You know that the domain is the set of inputs and the range is the set of outputs. Now specifically for parabolas, the domain, when we're graphing just an isolated equation, is all real numbers, always. Now when we get into real life situations, that'll change. And then the range is the set of outputs, and that will, in vertex form, we can look at the k value. And so we can help the k value know, the k value will help us know the range. So let's go ahead and graph. Here are the steps for graphing in vertex form. The first thing we want to do is pick out the vertex. Then we'll find that axis of symmetry, the line down the middle, and then we'll make a t-chart, and then from the vertex plug in two x values in the negative and two in the positive direction. So from this equation we can pick out h and k. H is -3, k is 4, and so that's my vertex, -3, 4, and that's where I will start with my points. Then I'll go 2 in the negative direction and 2 in the positive direction. When I plug in -4, I'll get +2, and -5, I will get -4. And the same with -2 and -1 because these points are symmetrical. So draw your xy axes. Oh, I missed on that one. Label your scale. And then let's graph points. So -5, 4, -4, 2, and let's try that one again, -5, -4, -3, 4, -2, 2, and then 1, -4. When you draw your parabola, make it a nice smooth U-shaped curve through your points. Put arrows at each end to show that it extends. So the domain and range. Domain, that's the set of the x values. What can we plug in that'll give us a real number? Well, there's any number that we can plug in for x, because we can square negatives or zeros or positives, so any number will work and give us a real number output. For our range, however, we look and we see, look on the y-axis, and you look to the left or right to see where the graph is. Notice that the graph starts across from where y is 4. That happens to be the y value of the vertex. So for the range, we can look at that k value. If the graph opens down, your range will be less than or equal to that number, and in this case, it's 4. Now let's look at example 2. So we'll pick out h and k. We've got +3, +7, and that's our vertex. We'll make two values in the negative direction, so 3, 4, 5. That's the positive direction. Now let's go -3, 2, 1. plug those values in. So when we plug in 4, we give about 7.7. Sometimes you will get a decimal, just round it tenths place. 9.7. And then 2, you'll get those symmetrical values. All right, draw your XY axis and label your scale. So we'll go 5 and then up almost to 10. 4 almost to 8. 3, we'll go up to 7. And 2, and then 1. Miss those points. Let's try that again. There. Now, so we've got our vertex, axis of symmetry. All right, draw a line straight through the vertex, and let's dash that line because it's not, we won't make it solid. It's not a permanent part of our graph. So the axis of symmetry always goes through the vertex. It's a vertical line, so it's in the equation x equals a value, and in this case, it's 3. So the axis of symmetry is always x equals whatever the h value is, the x value of the vertex. Okay, domain, you remember that from last time, all real numbers. The range, we're going to put our eyes on the y-axis, look to the right, see that the curve starts where the y value is 7. We also see from the equation, that's our k value. Since it's opening up, that means all those y values are going to be greater than or equal to 7. And that's our range. Now pause the video and go do the independent practice problems, and then come back and you can check your answers. Alright, so on number 1 of the independent practice, we'll pick out our h and k, -1 and 0, and start with our vertex. So we'll go 2 in the negative direction and 2 in the positive direction. Plug those values in. -12. Now remember when you're graphing that you are master of your graph, so you can change your scale if you want to. So I notice that I'm going to need to go to -12, so I am going to bump up my XY axis to here to give myself a little bit more negative space in my Y values. Label my X and Y axis and my scale, and then plot those points. 3, 5, 10, 12, 2, 3, and then -1, 0, 0, -3, and 1, -12. And then just draw that nice smooth U-shaped curve through your points. Locate the vertex and then dash that vertical line, that axis of symmetry, right through there just to show. And let's write our axis of symmetry is x equals, and it's going to be the x value of the vertex, so in this case that's -1. So that's our equation of our vertical line. That's our axis of symmetry. Domain, all real numbers, just like before, because we could plug any x value in and get a real number out for our y value. And then range, so we'll put our eyes on the y-axis, we'll look to the left, and notice the curve starts where y is, where y is 0. So let's change that point, -1, 0. So our range will be all the y values that are less than or equal to 0. All right, and on number 2, pick out your h and k. So we have +2, +5. Our vertex is at 2, 5. So we'll go 1, 0, and 3, 4. When I plug in 1, I get 7, and 0, I get 13, and then these values will be symmetrical. So now I've got my eyes here, and I notice my y values, they go all the way up to 13. So I'm going to adjust my xy axis. And remember, you can do that. Label your scale. Five, 10, 11, 12, 13, 1, 7, 2, 5, and over 3 and up 7, and then over 4 and up 13. Now you should be getting used to or start recognizing when graphs are wider or narrower than the parent function, just y equals x squared. So this one should feel a little narrower to you. If you look at the a value, that's 2. It's greater than 1, so that means it is a vertical stretch. The graph's narrower. Our domain will be all real numbers, and our range, if we put our eyes in the y-axis, the graph starts where y is 5. And then it opens upwards, so all the y values greater than 5 and including 5 are used. Last thing, let's sketch in that axis of symmetry, and let's just write the equation of that. Remember, it's the x value of the vertex, so the axis of symmetry is x equals 2. All right, and that is, for now, all the important characteristics of the graph of a quadratic function.